So welcome to another segment of our video. So it's the question here says that 1 mole of a carbohydrate burns completely in oxygen, producing 220 grams of carbon dioxide and 90 grams of water. So the question says determine the chemical formula of this carbohydrate. And then they tell us note that the ratio of hydrogen to oxygen in every carbohydrate is simply 2:1. So if you look at the data that we have been given, I want you to know that since they are talking about 1 mole of a carbohydrate, the general form of any carbohydrate can be written as CN, H2N, then ON. So this is the general form of any carbohydrate. So what do you need to do? Well, I can simply tell you that in step 1, what you're going to do is that you need to find the moles. So you are going to find the moles of carbon dioxide. So how many moles of carbon dioxide? So if you notice in the question, they gave us, in this case, 220 grams of CO2, and they have also given us what was produced, so that is 90 grams of H2O. So what you're going to do is that you need to find the number of moles in carbon dioxide and find the number of moles in water. So let's start with the number of moles in carbon dioxide. Now if you were to find the mist of CO2, you are going to realize that here there are 2 atoms of oxygen times the atomic mass, which is 16, to give us a 32. Carbon is only 1 times 12, which will give us a 12. So when you add that, it will give you a 44. So therefore, if you remember, number of moles is equal to mass over mist. So what is the mass of carbon dioxide that was produced from the when a carbohydrate was completely burned in oxygen? So they are telling us it's 220. So we are going to say 220 grams divided by 44. So what is that going to give us when you divide, in this case, 220 divided by 44? So you are going to have actually 5 moles. So that produces 5 moles. Now what we are going to do is very simple. I'm going to say that 1 mole of carbon dioxide is equal to, so from this guy you're able to see that 1 mole of carbon dioxide, there's only 1 mole of carbon, there's only 1 carbon. So we are going to say there's 1 mole of carbon. So now you are going to get these 5 moles and say, suppose I have 5 moles of CO2, then how many moles of carbon are there? We don't know. Then we can cross multiply. So 1 times x will give us x is equal to, and that will be 5 times 1, that is simply going to give us 5 moles of carbon, so which we can write as C what? Which we can write as C5. So we are simply going to do the same when it comes to to the water. So in step number 2, I'm going to say again that you need to find the moles of H2O. So remember, the mist of H2O, oxygen is 16 plus there are 2 atoms of hydrogen, so the mist is going for water is going to give you 18. Therefore, number of moles will be equal to mass over mist. So the mass that was produced is simply 90. So that is a 90, but you divide that by 18. So what is that going to give us? So that is going to be 90 divided by 18, which is going to give us, which is again going to give us, 5 moles of H2O. So now, the next step that you're going to do, you're going to say, okay, fine, if 1 mole of H2O produces how many moles of hydrogen? So here there are 2 atoms of hydrogen in the water. So 1 mole of water, produces, you can say, 2 moles of hydrogen. So you are going to take these 5 moles for water that we have found and simply say, okay, suppose I have 5 moles of H2O, then how many moles of hydrogen are there? We don't know. Then we can again cross multiply. So x will be equal to 1 times that will give you x, then 5 times 2 will simply give you 10, 10 moles of hydrogen. Now, once we have found the number of moles of carbon and the number of moles of oxygen, so in a carbohydrate contains carbon, hydrogen, and oxygen. So we need to know how many moles of oxygen are there. Now remember, they told us that note that the ratio of hydrogen to oxygen in every carbohydrate is 2 to 1. So we can make use of the ratio there. So I'm going to say, let me use a different marker. We know the ratio is of hydrogen to oxygen is simply 2 to 1. Now, since I know for hydrogen it is 10 there, so I can say, what about if I have 10, then how many moles of oxygen will that give me? We don't know. Cross multiply that. This times that will give me 2x is equal to 10. Then to find x, I'll divide 2. I'll also do it the other side. So meaning that x, when this and that cancels, will give me 5 moles of, so you have 5 moles of oxygen. That's what we mean. So therefore, if you look at the formula for the carbohydrate, because it says determine the chemical formula of the carbohydrate. So for carbon, it was simply a 5. Let me use a different marker again. So for carbon, it was 5. For hydrogen, in this case, if you look at for hydrogen, it was 10 there. And if you look at the oxygen that we have found, it was simply 5. So this is actually, the chemical formula of the carbohydrate. And you can see that the ratio of hydrogen to oxygen is simply 2 to 1. Thank you so much for watching. Watch out for some other video.